Okay, this is going to be a speed run of my presentation I gave last week at Unite on multiplayer debugging in games that are mixed reality games, but actually can be applied to just about any other game. And the update on the text here is that it was previously called Unity Game Services, now they call it Unity Cloud. Assume that you know who I am, and I'm going to assume that we can skip through the agenda here pretty quickly. Quick note on what sort of the focus of this is, which is party versus a multiplayer party game with 2 to 4 players, Quest exclusive. The games themselves are pretty quick, short matches with fast physical play. But again, you can kind of learn more about this just by watching the video, and I'm not going to actually share the video here. We're just going to move on and pretend we did. Technology here that we used was Unity 2021 and with Fusion with the shared authority topology. But again, we're kind of going to skip through all of this and kind of focus on the specific challenges we were solving, which are those related to the device. Kind of working with the headset, the debugging of multiplayer code, and support for QA. Specifically, what we're focusing on here is once a bug has been found, how do we ensure that we're fixing the right bug? Not so much how do we find bugs themselves. Kind of this real quick overview here on just one of the challenges that we face when we're working with MR. This is from Sean Patton, is that a lot of the bugs that we're going to be facing have to deal with the challenges around players' rooms, players' levels, and the world that they're bringing to the game themselves, their physical space. So when we're talking about the challenges related to the device, really the focus here is on the bugs that may be related to things that are happening on the platform. An example of this was basically every time we would get an update, sort of early days from the platform, from Meta. This was happening on, I think, the 7th of the month, every month. Something would break. And so really understanding what is breaking became is this new bug related to a platform update, or is this new bug related to something that happened in our code? Bugs also may be related to, again, the physical space, and anything we could do to get that information to the engineer who is going to, later fix the bugs to understand would be helpful, specifically with the knowledge that by default logs that come from Unity's logs, whether it's your log error, your debug log warnings, or just any kind of log item you might add, don't actually hit Android devices. And so we needed a way to have them on device and pull them quickly. We'll talk a little bit about that in a minute. Other challenges are specifically related to debugging multiplayer code, right? So limited support for multiplayer testing on desktop. There is now the multiplayer feature within Unity, but they're again, limited support specifically around making that work with, what was coming, the data that's coming from a headset. So while we could run a single Unity instance to sort of simulate a sort of an empty room, getting actually data that represents the actual room in a multiplayer session was a challenge. And an example of this is there was a situation where we had a bug when you would spawn a potato in my room. I would throw that into your room. That potato would bounce against the walls as we'd expect because the collision for the potato was set to collision detection mode, continuous dynamic. But when you then picked it up and then it transferred state authority from me to you, your local instance would have the collision detection mode set correctly, but for me on my headset, my local collision the collision detection mode would be set to discrete. That was the bug that was happening. So what would happen is you would then throw it against your wall and it would bounce correctly, but when you threw it into my room and my simulation took over, it would go through my wall. So you could toss that potato through my wall because it was using discrete detection mode instead of continuous. And this is just an example of a bug that was, particularly hard to find and particularly hard to repro with a single instance of Unity, or even with 2 instances of Unity running locally. It really had to do with sort of the challenges around either 2 players or 3 players. Basically, bugs would fall into one of 3 categories: either bugs that happened, with yourself, bugs that happened in a 2-player game, or bugs that happened in 3 or more player games. And for us, we had maximum of 4 players, but that was the real challenge there. The other challenge is that we're kind of focusing here on is the challenges associated with supporting QA. It is a lot of work for a QA team to see a bug that's happening sort of middle of the game, recognize that it's a bug, stop playing, have someone note the timestamp, collect logs. We're of course looking for logs from the device as well as video associated with that, and then anything related to the just sort of syncing this happened when at this timestamp. It just is a real challenge just to collect those logs and then have enough information that when a engineer got the Jira ticket, they could do something useful with it. Kind of a funny anecdote related to this was that the QA team, which was based in the UK, would be recording video, and they would then send the video along with a bug, and they had muted themselves because they were just chatting amongst themselves, and they didn't really want to include that with a bug because they didn't feel that was relevant. But of course, for us, it was entirely relevant because we could find out what they were doing right before and what right after. There was a lot of information that we could glean from the conversation that was happening during the experiencement of the bug. Little subtle things that were said would help us understand what exactly was the bug related to. So that's basically the 3 challenges we want to focus on, and the solutions that sort of a combination of tools that we used, including Unity Cloud. Okay, so the first was, solve this problem with multiple instances of Unity, and I know a lot of people have done this in other multiplayer projects, but really became important for us, especially once Meta made available the Meta XR simulator. So what we use is symlinks. Basically use this. I've got a command line here, mklink, that you could run in a batch file to basically make a symbolic link between an assets folder here and another directory. In this case, I'm calling this peer 2 of the assets folder. You could do that with your assets folder, do that with your packages folder, do that with your project settings. And then what you can get is basically a duplication copy of that folder structure that would then allow you to open up a Unity editor in that other sort of subfolder. You could do this with basically 4 peers, or a total of 4 Unity instances. I ended up having peer 1, peer 2, and peer 3 along with the original folder. Each one of those can then be associated with their own Meta XR simulator, or actually ideally 3 of them connected to the simulator and 1 of them connected to an actual headset via a link cable, and then being able to run the game and get device information. One note about this is by default you only get 1 editor log from this experience because it's considered to only be 1 editor, and so you only get 1 editor log. And so one of the changes I made to our logging code was to not only allow logging on Android devices, but also use the full path where the currently instance is of the assets directory and embed that in the log name so that we could then have multiple logs for each editor, even when running in sort of locally. The logging system allows us, and this is again sort of code that we built internally and was sort of added to through this project, allows us to very easily grab log events and send them to a file. I will cover the code sort of all at once instead of kind of jumping back and forth here, just so we can quickly review it. Again, making this the Cliff Note versions of this presentation. The second one is the crash monitor. So again, whenever we have an exception happen, so for example, a null reference exception, the hope is we can immediately flag that so that this becomes a bug that the QA team can write down and notify us about, and not continue playing because of the challenges around hitting a bug. Early in the game, you might be playing later, and if you come up with another bug, that may be associated with the first occurrence of the bug. So we don't want the players to continue playing. What we want to happen is we want them to, the QA team, to stop, submit the logs, and quit the game. And so that's what we've got here is this little pop-up that happens in headset. There's a button that says submit and quit. And that ensures that we are able to quickly gather those logs, have those logs available for the QA team, and not be in a situation where a log later is occurring, or sorry, an exception occurs later that is related to the first log, for first error. Basically, what we want to do is them to quit and start the game again, and find new exceptions. One of the things to note here is that, we said this early on, it was just, you encountered a critical error, null reference exception. And then what we get is we get a Jira ticket that said, critical error, null reference exception, which looked like a million other Jira tickets. So later on, we updated the text, actually to pull out the important part. What we really care about is there's an exception in apply new primary corner. That's the exception that we want to understand. So changing sort of the layout of this message so it becomes easier for the QA team to write a Jira ticket that is relevant to, what's actually happening. And in the example I'll show you, it won't actually happen, but you could also do a sort of pop-up to say the log was successful, the submission was successful. But what this screen shows is that we also added basically an encoded timestamp, and as well as the player's name. So in this case, Sean was playing, so S Patton, and EADQM represents basically a date, hour, second of a particular point in time when this log was occurring. So you could easily sort of collate logs from the different players. So theoretically, if I'm playing with Sean, I'm going to have a report ID that matches my user ID. So, Alaska John dash EADQ, and maybe it's going to be P as the last letter because it was within seconds of the time that Sean submitted his log. And then we could then, from a QA perspective, quickly pull them into the same Jira ticket. And then when the engineer gets those logs, they could, know that these two logs are related with these two timestamps and sort of quickly understand, where the game was across the multiplayer session. And so the final piece of this is this part of actually submitting the reports. Again, we're calling this not Unity Game Services or UGS, but Unity Cloud. And there is a system by which you can use user reports. Normally, these user reports are built for use by players in the real world playing the game. But in this case, we're very much focused on these are logs to be used during development and, sort of our QA cycle, not something we actually intended to ship with the game. You have the ability to include screenshots. Ours don't include screenshots because it's a little bit of a hassle with VR and we didn't really need it. But what we really did need was sort of these device logs, and that became super helpful for us. So we'll take a look at that as well. Also important as part of this process is we can then integrate these logs or these reports with either email or Slack. I'll show an example here in a minute of integrating with this email. But what we did was we integrated it with Slack. An email, you already get sort of an email with Cloud Diagnostics, and this is useful in itself, but we're going to kind of go deeper with user reports. And here's an example of what we looked like, what our Slack integration looked like. And really what we're looking at here is the scene name, the ID of and it's actually this whole portion here is the ID of the QA tester, that timestamp, and then, in character form. And again, the idea here is, maybe we've got multiple players and they're playing, and then we've got somebody else taking notes. It's really easy if it's, again, here's an example of BOF. LZ is one player, BOF U is another player. Somebody taking notes could write that down and use it, kind of look that up later to be able to sort of, again, collate between play session. And, finally, this is kind of a look at the Jira log. In this case, we've got 3 video files, 3 text files representing those logs, and this becomes very easy for us to really understand what's going on, be in a situation where the engineer who is getting the log, or getting the Jira ticket, can understand what is happening with this particular ticket and create a solution that they feel confident about, not be in a situation where they submit a fix and then only to come back, the next day and say fix failed or there's nothing worse than having fix failed. No feeling worse, no feeling better than having, fix verified. And so trying to make that the norm. So let's jump into a live demo. I am going to pull a screen over here. I'm going to do a new project. Once I kick this off, I'll then pause the video recording just to allow it to load up here. But let's call this Unite 2025. We'll call this, quick version, because we're doing this as fast as we can. So let's kick that off. I've got my org and I've got, this is all fine, whatever. So let's go ahead and let that start. Okay, so we've got the basic scene here loaded here, the Unity project loaded. I'm going to go to Windows Package Manager, and I'm going to user reporting. And this is going to be in the Unity registry, user reporting. And this is something that is now a separate, with Unity 6.2, this is a separate package, not part of user diagnostics, or whatever they call it now. But previously, this was sort of part of that package. Now, Unity Diagnostics comes with Unity 6.2 out of the box, but Unity 6.2 does not include user reporting. They've got a different reporting that has everything to do with the way you report diagnostics and nothing to do with user reports. So don't let that confuse you, but we've added that. Now I'm going to switch over to, this is actually my website. I've got a post about this topic. There's a download file here. We're going to download that zip file. Let me go ahead and get us back here, and let me open up that zip file. Okay, I've got the zip file opened here. I'm going to then just, go ahead and show an Explorer so I can see both of these. This is my assets folder. I'm just going to bring these prefabs and scripts right in there, and then we'll take a look at what they actually do here in a moment. Okay, so now that we've got them there, the first thing we need to do is we need to create I'm going to just bring in a little piece of UI here, Text Mesh Pro, just so we can import these essentials, and we get a canvas and event system. I'm not going to do anything with this, but I need this to exist just as part of the, we need a canvas and we need Text Mesh Pro elements as part of this example. In the prefabs, I've got this crash monitor. I'm going to pull that in. So Crash Monitor references the user reporting and the pop-up prefab, and we'll take a look at those here in a minute. But what we're really looking at is back in our scripts file. I'll take a look at what we've got going on in the scripts. So let me go ahead and open those up for you. Okay, the first one we're going to look at here is we're going to look at the boot, which actually just does nothing more than kicks off on the start, sort of on this after assembly is loaded, the logger.start. And the logger is the part of the code that actually runs, grabs the logs, intercepts the logs. So we've got a log message that's a condition and a potential stack trace. And we've got down here in start, we've got this on log message received. What are we going to do when we get log message received threaded? We're going to do on log message received. And what does that do? Well, that just goes and adds a message to a queue. In this case, I've added a sort of a timestamp here to the condition and the stack trace if it exists. And then we're just writing to a file. And so you can just run through that code on your own, but that basically is just got a stream writer and we're writing to a file. And that is what allows us to get the log messages recorded to a file. And you'll notice up here that there is a note that if you're on an Android device, you need to make sure your Android manifest includes the right permissions, in this case, read and write. So that's the logging portion. The crash monitor portion is, again, we got the crash details, which is a condition and a stack trace. We'll look at what this looks like as far as the prefab itself. But the important thing to know here is we are looking to on log message received, and then this, of course, this soft crash detected, which will be our own to sort of monitor when we get messages from the system. In this case, we're only looking for asserts. Actually exceptions and asserts, and we're going to do something with those. What we're going to do is we're going to call soft crash mode detected. And so what are we going to do with that? Well, that then comes down to this show exception pop-up, which is down here. Show exception pop-up. There is some quick checks. There's also, you'll notice should we suppress, which basically says, are there any messages that we need to sort of ignore? Here's an example of one of the messages we might ignore because we don't want to throw exceptions for something that we already expect to happen. So on that exception or on all the other exceptions being received, we've got a pop-up, look for a canvas, instantiate a pop-up, get the message set correctly, and basically we're done. The last point worth noting here is we have the ability to have a context menu, and that's how we're going to simulate, for the purposes of this presentation, we're going to simulate some exceptions. So we'll take a look at that in a moment. And sort of the last important part of this is the Unity Cloud reporting mechanism, which is the ability here to send one of those user reports. Again, this is some boilerplate code that came from the user report system, as well as some additional work we added at Shell Games. But what we're looking at here is, again, some startup stuff, which is, we're going to configure, make sure that the user reporting client is configured correctly. There is, sort of setting this up. This is important. The Unity service is initialized. Basically, get everything set up, and we can configure the user reporting system. And then when we want to create and submit a user report, we are going to get that unique ID. I'll take a look at what that's a timestamp, turning that into a set of characters. And then if everything works well, we're going to create the new user report. We're going to submit the new user report, and then we're going to fire a callback. In this case of the submission of the user report, there is some adding some sort of metadata. This is all provided out of the box for the system. And then, of course, the important part is, I think, where is that at? Where we actually grab the log file. We're going to try to attach a log file here, which is being called somewhere. Anyway, we're going to find all references to that. So I've got it referenced. There we go. On success, we're gonna try to attach the log file. Let's take a look at that again. Go to that definition, and that's just going to go find that file where we told it existed, and we are going to, that's where it existed. That's what we're going to name it. We're going to name it something unique so that it shows up well in the report, and then we're going to add the attachment to the report. And hopefully everything works, and if it doesn't, we'll catch some exceptions. This last part is this converting the date to these characters. Basically, we've got the month, day, the hour, the minute, the second, and we're going to convert those to characters. Well, how do we do that? Well, the cool thing is it's just kind of convenient that since we have 60, so worst case scenario, 60 minutes, 60 seconds, less if you're talking 24 hours or 12 months, but we've got a number from 0 to 59. We're going to convert it to a character. So if it's the first 26, it's going to be a capital character. If it's the next 26, it's going to be a lowercase character. And the last, we're going to just sort of fill in the digits there, make sure we replace a 0 with a 1 because we've got an extra digit to work with, and we don't want to have confusions between big O and little o and 0. And of course, there is no 0 here, so we should know if it's an O, it's going to be a capital O, and then we get that character. And that's all there is to it. So let's take a look at what this actually looks like in game. Again, all I've done is brought in the crash monitor. I've created user reporting. User reporting automatically is connected because of my account information to the Unity Cloud. So if I run this thing, we'll get basically nothing's going to be happening here because it's just an empty scene. But if I go to the crash monitor, which is now on the don't destroy on load, we've got these sort of values here. I can set whether or not we monitor crash variable. So let's uncheck that and just note that if I right click on this and it says simulate an exception, I do get in here an exception, but we do have no pop-up. Of course, we do want a pop-up in this case, or we maybe want to build some builds with pop-up, some builds without, so we can do that. I'll go ahead and add the stack trace just so we can see it, and then the log and quit on crash, just so we can see that happening as well. So I'm going to right-click that, simulate the exception. We get this exception report, so we get the name of the exception. Again, that matches what's being here. We get the full, let's make this readable here. We get the full stack trace, and then I can do the submit and quit. Obviously, we're not going to quit on when we're in player. But you can see these logs have been successfully submitted. And now let's take a look at the email that, oh, I missed a step. Let's do the last step. We need to go, I haven't actually linked this to anything. So we'll get a log, but we haven't actually linked it to any of the integration points, like for example, an email. So let's do that real quick. We're going to go window, and then we're going to package manager here. We're going to find that user reporting. We're going to configure that. Let's see, and then we make sure that's in the screen. We're going to go to the dashboard. Go ahead and open that dashboard. We're opening it here. And let me scroll this down here. And what you're going to notice when I pull these all over here, what you're going to notice is that the page has not been found. And that is because it hasn't been converted over. The user reporting isn't part of Cloud Diagnostics yet. So this is a sort of a thing in transition. So what you want to do is you want to find Cloud Diagnostics, and you'll notice that user reporting's here. Again, this is the old Cloud Diagnostics. So if you click on this, it's going to say, hey, Cloud Diagnostics has been depreciated in both the debugging symbols and the crash and exception reporting, but user reports hasn't. So for all of your Unity diagnostics, you're not going to use Cloud Diagnostics anymore. You're going to use their new Unity Diagnostics. But if you want to use user reporting, you're going to have to go to the old Cloud Diagnostics to find where user reports show up. We have this one, or are we in the right? Let me switch over here to the right. This was the one we just made, so this is the quick one. And now we need to add an integration. So let's click on Add Integration, and we're going to scroll down to the bottom here, New Integration. I'm going to do Email. I'm going to say Test Integration Unity 2025 or Unite 2025, and I'm going to select myself as a recipient. I'm going to check these boxes here, and I'm going to create. So that's this new integration, email integration here. And then so now we need to switch back to our project and fire off a new report. So let's close these things up and let's switch over here. So we're still running. Theoretically, all we've changed is things on the back end, so we can run simulate a new exception. Here's a new exception, submit that and quit. And we've got a new update with OTAFZL as our secret code to look up. And it will take a few minutes, so I'll go ahead and pause this video while we wait for that email to show up. Okay, it took about a minute or about 5 minutes, and the report showed up. Again, Slack is best because you kind of get, the Slack notifications are really helpful, but let's go ahead and click on this. We get this cloud diagnostics. You can see you can click on the link directly to the report. The report comes through, and let's actually switch back here so you can see what it looks like from this perspective. Again, I've got 2 reports today. This is the one that we just got, the OTA FZL one, so let's go ahead and click on that. Here's the file. It actually is really cool because it's got a bunch of metadata here that's super useful. But for us, we've added an attachment, and the attachment is right here. So let's go ahead and download that, and we can then open it up and take a look at that. And here is the attachment. And this is, again, the logs that we just saw. Again, we have included, because we had the checkbox, we got in the full Slack trace. And this is the log file that we just kicked off with our initial exceptions there. That's it. Really not that complicated, but super, super useful when it comes to sort of pulling in all of these logs together for the purposes of our, supporting QA to get useful logs. So let's go ahead and take a quick look at some of the MetaQuest specific things. There is a reporting tool within the MetaQuest system. It's okay. It actually is great that it's there, but it doesn't offer really all of the features that we just shared. But it does have the ability to press a button and get some mic enabled voice to text. Just noting that it's there. It's a little hard to find if you've got to dig through the MetaQuest dashboard and have or at least have a link to that. So maybe not as accessible as being able to pull these things into Jira tickets, but it's not bad. Another thing I wanted to mention is one of the things that our team had built was this ability to record once you get a room scan and you've got all of those spatial anchors, take those spatial anchors in as, a text representation of them. So in this case, we've got a room anchor with some GUID and, it's wall art and a position, and we could then turn around and represent that in Unity. And so we visualize what someone's room looked like to be able to do things like, oh, look, there's some weird thing happening with the system such that this cabinet is being recorded through the wall. And for us, this was a problem. There's, 2 walls here, that might have been a problem. But again, being able to visualize what's actually, happening with the data coming from a real person's room became really helpful when trying to, find bugs in the system. So what were the end results of sort of implementing all this with Partyverses? Well, first we had a very small engineering team for the last months of development. No reports were crashed, no reported crashes after launch. So we felt really good about sort of the state of the game, our ability to have made good bug fixes sort of prior to the end of the project. We had a happy client and a happy QA. And I think I got a note from QA, which was like, you're the best team we've ever worked with, and your game brought us closer together our team closer together. There's a little bit to do with the game itself, but a lot to do, I think, with the attitude we had of taking our QA team seriously and ensuring that they had the tools they needed to sort of, feel confident about the bugs they were creating. A couple notes, I kind of mentioned these already, but sort of prior to Unity 6, user reports were part of the Unity Cloud Diagnostics, which was a separate package. Now Unity Diagnostics is part of Unity 6.2. User reports are separate packages you have to install separately. And of course, there's a little bit of confusion as to where they show up in the Unity Cloud dashboard. Big thanks. The initial logger was written by Bill Roberts. Ryan Broly did the initial crash monitor, and a lot of work on really understanding how exceptions are handled with async code by Jason Pratt. I haven't gone into a lot of that because a lot of those issues, I believe, are fixed with Unity 6. But if you're using an earlier version of Unity, you may have a situation in which your async exceptions get lost. And if that becomes a thing, there's a lot of information online about how you can really understand why async code might be losing your exceptions. So if that's something that is happening to you, it might be worth looking into that because the crash monitor won't catch them. Big thank you. Here's the URL, again, for my website to be able to find the code to download. And then there's a QR code to my LinkedIn if you are interested. Thanks, and reach out if you have any questions.